Before time existed, before space was born, there was only a singularity. A single point, smaller than an atom, containing everything that would ever exist. Then, approximately 13.8 billion years ago, everything changed. In a fraction of a second, the universe erupted into existence. The early universe was an unimaginably hot and dense fireball, hotter than the center of any star, a churning ocean of pure energy. In the first 10 to the minus 43 seconds, known as the Planck ep, the very fabric of space-time was being woven into existence. Then came cosmic inflation. For just a moment, the universe expanded faster than the speed of light, growing from subatomic to galaxy-sized in a breath. As the universe cooled, the fundamental forces of nature split apart. Gravity was first, then the strong nuclear force, followed by the electroweak force. By the third second, quarks began clumping together to form protons and neutrons. This is where all matter that would ever exist started taking shape. Within 3 minutes, the universe was a nuclear fusion reactor. Hydrogen, helium, and traces of lithium were forged in the first moments of creation. For 380,000 years, the universe was an opaque fog. Light could not travel freely, trapped in a cosmic soup of charged particles. Then came recombination. The universe cooled enough for atoms to form, and suddenly light could travel freely for the very first time. That first light still exists today. We call it the cosmic microwave background, and it is the oldest picture we can take of the universe. Then came the cosmic dark ages, a vast, silent, and lightless expanse where the first atoms drifted in darkness for hundreds of millions of years. Gravity began pulling matter together. Dense clouds of hydrogen and helium gas collapsed inward, heating up and spinning faster with each passing million years. Approximately 100 million years after the Big Bang, the first star was born, a massive, brilliant blue star blazing to life in the eternal darkness. These first stars, called Population 3, were giants, hundreds of times more massive than our Sun, burning fiercely and dying young in spectacular fashion. When these giants died, they exploded as supernovae, spreading heavy elements across the cosmos. Every atom heavier than lithium in your body was born in such an explosion. These stellar graveyards became cosmic nurseries. The heavy elements from dead stars mixed with hydrogen clouds, creating the ingredients for new kinds of stars. Gravity wove these stars into the first galaxies, irregular and chaotic structures swirling together in the dark abyss of space, billions of stars at a time. Galaxies grew through constant collision and merger. Small galaxies crashed into each other, merging to form larger structures over billions of years. Over billions of years, chaotic galaxies slowly organized into the elegant spiral and elliptical shapes we recognize today. Order emerging from cosmic chaos. Around some of these new stars, disks of dust and gas swirled. Within these disks, the building blocks of planets began to collide and stick together. Our solar system formed about 9.2 billion years after the Big Bang, born from the remnants of countless generations of dead stars. Earth was born a molten hill. Volcanoes raged across its surface, the sky burned with constant asteroid impacts, and a moon recently formed from a devastating collision. The moon was likely formed by a Mars-sized object called Theia, smashing into the young Earth. The debris from that cataclysm eventually coalesced into our moon. Earth slowly cooled, the crust solidified, water vapor condensed into rain, and the first oceans formed in an atmosphere thick with carbon dioxide and methane. In those first oceans, probably near hydrothermal vents, chemistry became biology. Simple molecules combined to form the first self-replicating structures, the very first life. Over 2 billion years, single-celled organisms slowly transformed the planet, Cyanobacteria began photosynthesizing, filling the atmosphere with oxygen. The Great Oxidation Event transformed Earth forever. The sky shifted from orange to blue as oxygen accumulated, enabling the evolution of complex life. But the story does not end with Earth. The universe itself is still expanding, and that expansion is accelerating, driven by an unknown force called dark energy. In 1929, astronomer Edwin Hubble looked at distant galaxies and made a mind-bending discovery. They were all moving away from us. The farther away a galaxy was, the faster it was receding. The universe was not static, it was expanding like a balloon being inflated. In 1965, two radio astronomers accidentally discovered the cosmic microwave background radiation, the afterglow of the Big Bang, confirming everything Hubble had found. Here's the most humbling fact of all. Everything we can see, every star, every planet, every atom of matter, makes up only 5% of the universe. 27% is dark matter, an invisible substance that does not emit light, but whose gravity holds galaxies together. And 68% is dark energy. Our Milky Way galaxy contains 200 billion stars, and there are 2 trillion galaxies in the observable universe, each one an island of light in an ocean of darkness. At the center of almost every galaxy lurks a supermassive black hole, consuming everything in its path and shaping the evolution of the entire galaxy around it. The universe was far more active in its youth. 12 billion years ago, star formation was at its peak, with galaxies birthing hundreds of new stars each year. We now know there are at least 5 billion Earth-sized planets orbiting stars like our Sun in our galaxy alone. Every one of them was born from ancient starlight. In about 100 trillion years, the last star will burn out. The universe will become a cold, dark, and empty place, expanding forever into nothingness. There is a fundamental limit to what we can ever observe. Light from beyond 93 billion light-years has not had time to reach us since the beginning of time. The person who first proposed the Big Bang was a Belgian priest named Georges Lemaitre. In 1927, he theorized that the universe began from a primordial atom. In 1995, the Hubble telescope stared at a patch of sky so dark it appeared empty. In 15 days, it found 10,000 galaxies in that tiny square. Carl Sagan once said, "We are a way for the cosmos to know itself." Every atom in your body was forged inside a dying star. You are literally made of stardust. If you compressed the entire history of the universe into a single year, the entire history of human civilization would fit into the last 2 seconds before midnight on December 31st. The quantum world and the cosmic world are 2 sides of the same coin. The same physical laws that govern the largest galaxies also govern the smallest particles. Today, telescopes like James Webb peer back to within 100 million years of the Big Bang itself, watching the very first galaxies ignite in the cosmic dawn. The James Webb Telescope recently captured the pillars of creation in infrared, seeing through dust to reveal thousands of stars forming inside these cosmic mountains. Some physicists believe our universe is just one bubble in a vast multiverse, each bubble with its own laws of physics and its own beginning. We may never know. Every human who has ever lived, every triumph and tragedy has existed on this tiny, pale blue dot suspended in a sunbeam, in this unimaginably vast and ancient cosmos. From a single point of energy, the universe has expanded into a vast cosmic web of galaxies, stars, planets, and consciousness. And you, Milan, are part of that story. 13.8 billion years after the Big Bang, the universe continues to evolve, to create, and to surprise us with its beauty and complexity. The universe has no end, Every death feeds new life, every explosion seeds new stars, and the story of creation continues still, to this very day.